The ZIMO system distinguishes between libraries and databases. Libraries are collections of vehicle images, including labels and parameters, function symbols, and depictions of points and signals, amongst other things. In other words, mainly GUI components used to represent the available vehicles and fixed installations on control devices. Libraries are provided by ZIMO and are continuously updated. Depending on their use, they have names such as Rolling Stock Library, Accessory Parts Library, or Function Symbols Library. New libraries and updates to existing ones are downloaded via the Connect screen. In addition to the official libraries, it is also possible to create private additional libraries. However, the software required for this has not yet been finalized. Unlike libraries, databases are created by the user, usually within the controllers themselves, that is, in controllers such as the MX32 and MX33, and on smartphones running the ZIMO app. The basic types of databases are those for vehicles and those for accessories, also known as stationary installations. A complete digital system consists of a digital center, in ZIMO's case the command station, and at least one, usually several controllers, control panels, and apps. Accordingly, there are system-wide databases and device-specific databases. The latter contain only those vehicles and accessories that are to be used on the device in question. The entries in a device-specific database always form a subset of the entries in the system-wide database. Of course, however, a vehicle may, for example, be present in several device-specific databases simultaneously and can be directly activated and controlled from several devices. On an app instance, the user therefore deals with databases named sysdbv, appdbv, sysdba, and appdba, where V stands for vehicles and A for accessories, switches. Essentially, the databases are lists of vehicles, identified by vehicle addresses and optional names. And similarly, points, signals, and other stationary accessories identified by accessory addresses and optional names. The display of the databases, that is, the list of vehicles or accessory items, also includes the current operating states, such as speed, preferably kilometers per hour from the Railcom feedback, direction, and the first 10 function states as a mini-table. This can be opened by tapping, and then all function keys become visible and selectable by scrolling. After all this theory, we now move on to the practical application in the ZIMO app. The Connect screen, which can be accessed at any time via the three-line menu, contains the libraries for vehicle images, accessories, and function icons for download. Clicking the down arrow starts the download and automatically installs the latest version of the respective library. If no arrow is displayed, the current version is already installed. These libraries can, for example, be selected and displayed as GUI elements on the driving screen. Tapping on GUI libs opens a reduced size view. Vehicle images and function icons can be browsed by scrolling sideways or up and down. The desired vehicle image is selected by tapping on it and then confirmed by tapping Confirm at the top of the bar. The app then returns to the driving screen and displays the selected locomotive. Tapping back, on the other hand, undoes the selections made. Function icons can be selected individually or conveniently in groups and assigned to the function keys. When a function icon is tapped, it is highlighted with a yellow border and displays the number 1. Each additional selected icon is numbered consecutively. The icons can then be placed on the function keys at the bottom in exactly this order. Here too, Pressing Confirm in the top bar applies the entries made. Back undoes the changes. Alternatively, both libraries can also be opened in a clearer full-screen view. To do this, call up the GUI libs again. At the top, you can then select rolling stock for vehicle images or function symbols for function symbols. As it is not very practical to manually scroll through several hundred vehicle images, and even more in future, there is a filter function for these. For the 232 series, for example, it is sufficient to enter the number 232 in filter 1 and confirm the entry by ticking the box. Now we come to the databases created by the users themselves. In the ZIMO app, these can be found in two ways. Firstly, via the familiar three-line menu. The databases are listed there, one below the other. Secondly, in the top menu bar, for example on the loco screen. There the icon changes to indicate the other database that is not currently active. So, if you are in the app DBV, then sysdbv is displayed at the top of the menu bar, allowing you to switch at any time. To recap, the app DBV is the database of vehicles that have been loaded into the app or created directly within it. App DBA is the corresponding counterpart for accessories such as points and signals. The sysdbv and sysdba contain all vehicles and accessories created in the app or at the controller. These are stored and managed collectively by the MX10 Central Command Station. Addresses created in the app are therefore automatically copied to the respective sysdb and are subsequently available to all controllers via the Central Command Station. An address is therefore always present in the sysdb, regardless of whether it originates from the app or the controller. In the app DB, on the other hand, you can select which vehicles or accessories are to be displayed and controlled in the app. Data can be conveniently imported from the respective system database into the app database, including the GUI. To do this, open the sysdbv. The app then loads the existing addresses from the MX10. This list can be sorted, for example, by tapping on the name or address. Under the blue Select All to Import from MX10 button, the switches can be used to select the desired addresses to be copied into the app. As soon as at least one address has been selected, the Import button appears at the bottom. Dark grey buttons that cannot be pressed indicate that this address is already in the app. You then switch to the App DBV in the menu bar at the top. The imported vehicles are now displayed there. The colours of the rows have the following meanings. Green rows show vehicles that have already been called up in the app and are therefore also in the loco recall LOR. Blue rows indicate addresses that have not yet been actively used in the app. Further and more advanced handling of the app DBS is covered in the relevant chapter of this tutorial. Here is just a brief overview of the most important options. Clicking on a vehicle opens it in the loco, aka driving screen. It can be controlled there. The blue Vehicle Manager button is used to enter new addresses. The database management function next to it allows, amongst other things, the deletion of addresses from the app DB or completely from the MX10. To do this, the desired addresses are selected and then the corresponding button is pressed. Importing from the sysdba works in exactly the same way as for the vehicles. In the app DBA, new switches can also be created and used.
Now to the important topic of libraries and databases. This is the entire organizational structure, which is why it is such an important topic. Some potential users might say that this all sounds very complicated. Elsewhere, the elements are simply entered and nobody needs to worry about the storage organization behind it. That is also possible with ZIMO. If there are only 10 vehicles, for example, it is usually not necessary to split them into separate system-wide, device-specific databases. That is what the All button in the import function is for. However, the ZIMO system is designed not only for small-scale, but also for very large-scale applications. That is, for a large number of vehicles and accessories. The more vehicles there are in the database, the better it needs to be structured. And the type of databases offered by ZIMO, both system-wide and device-specific, are, in other respects too, a ZIMO speciality. Why? Well, they are more than just a list of addresses, names and images. Operating statuses and Railcom feedback are recorded in real time, such as speed, direction, and the functional statuses of locomotives, vehicles and accessories.